Ever stop and wonder what makes all our modern gadgets tick? Your phone, your laptop, the watch on your wrist. What's the one single idea at the heart of all of them? Well, it's a concept so fundamental we don't even see it anymore. But today, we're going to pull back the curtain and take a look.
So let's go back to the 80s for a second. Ads like this one were selling a pretty wild dream, a personal computer in every single home. But to get there, computers had to become way more flexible. And the key wasn't just making the parts smaller. Nope. It was a revolutionary new concept that changed the whole game. So what was this big idea?
To really get it, we've got to hop in a time machine. We're going way back to the dawn of computing, to a time when programming had nothing to do with keyboards and everything to do with physically wrestling a giant mess of wires.
Yeah, you heard that right. For the very first computers, the machine was the program. The physical wiring literally determined what it could do. They were hardwired to perform one specific job, and that was it. The idea of software, it just didn't exist.
So think about what that really means. If you wanted to add a couple of numbers, you needed an adder machine with all its circuits built just for adding. Wanted to subtract? Well, you needed a completely different machine, a subtractor. So every time you had a new kind of problem, you had to build a new custom-wired computer. It was, as you can imagine, incredibly inefficient.
And even on the machines that were a little more flexible, changing the program meant you had to physically go in and rewire the circuits. One of the pioneers of the time called it a very tedious job, which has to be the understatement of the century. Clearly, this was not going to work long term.
And then, along came the solution, a truly revolutionary idea. And this is the concept that is, right now, humming away inside the device you're watching this on. It's called the stored program concept.
Okay, so what is it? It's actually a beautifully simple idea. What if the instructions, the program, could be stored in the computer's memory, just like any other piece of data? Instead of being a fixed set of wires, the program itself becomes flexible information that the computer can just read and execute.
This amazing idea was formally published way back in 1945 by the brilliant mathematician John von Neumann. It led directly to the design of the IAS computer, which was up and running by 1952. And this machine, it became the blueprint, the granddaddy of basically every computer that came after it. That's why we now call this design the von Neumann architecture.
So, that's the theory. But how does it all work in practice? To figure that out, we need to pop the hood and take a look inside the brain of the computer, the Central Processing Unit, or CPU. Let's see how it's built to actually use these stored instructions.
Okay, so right at the very heart of every CPU, you'll find the Arithmetic Logic Unit, or ALU for short. Just think of it as the computer's own personal calculator. It's the piece of hardware that does all the actual math, all the addition, subtraction, you name it. Now, the ALU is a powerhouse, but it can't just go fishing for numbers. The data has to be delivered right to its doorstep. And that's the job of the registers. They're these tiny, super fast little storage spots right there inside the CPU, holding onto the numbers the ALU is about to work with.
And here's where it all comes together. You've got the ALU ready to calculate and the registers holding the numbers. A control system acts like a traffic cop, directing the whole show. It tells the registers which numbers to send, tells the ALU what to do with them, and then tells the result where to go. It's this incredibly fast dance of data.
And the most amazing part? This whole complex ballet is kicked off by one single instruction. Just a simple string of ones and zeros that the CPU reads from memory. So let's actually break one of those instructions down. Okay, so this might look like gibberish, but to the CPU, it's a clear set of directions. It reads the code in chunks. That first part, 00, that's the opcode, or operation code. It tells the ALU, get ready to add. The next part tells it where the answer goes, in this case, register 3. And the last two chunks tell it where to get the numbers from, register 0 and register 1. In a flash, this line of code becomes a real physical action inside that chip. So that's the nitty-gritty of how it works. But the real story here is the legacy of this idea. This is what took us from computers that filled an entire room to devices that we now carry around in our pockets. This quote really says it all. You know, with a few very rare exceptions, every single computer today, your laptop, your phone, the servers running the internet, they are all fundamentally von Neumann machines. They all operate on this exact same core principle.
And this comparison just drives it home. On the one hand, you have the promise of an early personal computer. On the other, a modern CPU.
It's the exact same underlying concept, but today's chip is doing the job billions of times faster, in a space smaller than a postage stamp. It's just wild.
So, why does this matter so much? Why is this the big idea? Because this is what created the split between hardware and software. It's what makes a computer flexible. It's the reason you can play a game 1 minute and write an email the next. This one idea transformed a clunky, single-purpose calculator into the universal tool that has completely reshaped our world.
So just think about that for a second. The basic architecture, the brain of your computer, is based on a concept from 1945. Yeah, we've refined it and shrunk it down beyond imagination, but the fundamental idea is still the same. Which leaves us with a pretty fascinating question, doesn't it? What's going to be the next revolutionary concept that defines computing for the rest of this century?